Okay, now we're going to go back in this lesson and talk about some things that we learned before about quadratic functions when we learned how to graph a quadratic function. So I'll just do a quick little review of quadratic functions in general. So if we're talking about a quadratic function, we're talking about y equals ax squared plus bx plus c. And so this is the standard form, if you remember, of the quadratic function. Now, since we had a y value, we weren't solving this quadratic function, but instead we had two variables. We had an x variable and we had a y variable. And so this would allow us to go through a process to help graph the quadratic function. And when we were learning how to graph quadratic functions, we actually taught you three different methods. We taught you the standard form, which required you to use a formula to find the axis of symmetry, and then use that to find the vertex. Then we taught you something called the vertex form. And if you remember, it started this process of learning about h's and k's. And this was called the vertex form. And basically, we could take the h value and the k value, and that was going to give us the vertex of the parabola. And then lastly, we talked about the factor form, x minus p and x minus q, and we would call that the intercept form because it gives us the two x-intercepts of the quadratic function. Now, what I want to show you today is that given the standard form of a quadratic function, if you wanted to graph this and you were uncomfortable with the process of the standard form, there's actually a way to convert the standard form to either the vertex form or the intercept form. Now, in previous lessons, we've talked about this, and we found out that if the quadratic function was factorable, we could actually take this and take the standard form and change it to the intercept. Now, in changing this to the intercept form, we basically called that the factored form in the past. Now, what happens if it's not factorable? Well, in this case, what we can do is we can actually take the standard form, and using the completing the square process, we can actually change it to a vertex form, which would make it much easier to graph. So, if you remember, in graphing quadratics, the vertex form and intercept form in many ways was a little bit simpler, and it took a lot less steps than the standard form. So if you're comfortable factoring, or you're comfortable doing the completing the square process, you can take a standard form quadratic function at any time and change its form using the two processes. So what we're going to do is get a little practice in changing quadratic functions to vertex form for this lesson and completing the square. So if we look at example 3, example 3 is going to give us a quadratic function, and if we look at x squared minus 8x plus 11, we should be able to recognize at this point that that is not factorable. So this is a point where we can actually create a vertex form through the completing the square process. Now, just as I have done before, you need to go through the process of kind of giving yourself these little blanks to fill in the completing the square process so you can create that perfect square trinomial. So in this case, we kind of moved the 11 out of the way a little bit and created some parentheses to create the perfect square trinomial. And as always, whatever we do to one side, we have to do to the other. So if we go through the completing the square process, we recognize that we get 16. And so we're going to add 16 to both sides. And then, of course, it creates a square of a binomial, x minus 4 squared. Now, what we've done here is in that square of the binomial, if you recognize the vertex form, x minus h squared is actually a square of a binomial. So we're most of the way there at this point. All we really need to do is subtract 16 from both sides and get y by itself. And when we do that, we are actually going to have the vertex form of a quadratic function. So this is a good example of how you could change the form of a quadratic function to suit your needs for graphing or ways of solving a problem if necessary. So let's take a look at a couple examples. In this case, we have sample problem number 4, part A and part B. So what I'd like you to do right now is just go ahead and pause the video and work both of those problems in changing the quadratic function to vertex form. So take a second to do that now. Alright, so let's take a look at this. I'm just going to create some space for myself, and I'm going to say y plus some value, and x squared plus 6x plus another value, and I'm just going to kind of move that 16 out of there. Now, if we recall, the completing the square process is b over 2 squared. So the b in this case of the trinomial that we're trying to complete the square for is 6. So 6 over 2 squared, which is 3 squared, and c equals to 9. So I'm going to add 9 in there to make that a perfect square trinomial. And of course, if I do that, I have to do it to both sides. So I can rewrite this, however, as y plus 9 equals x plus 3 squared, and then of course I've got to keep my 16. So now I have a square of a binomial over here, which gets me most of my way to my vertex form. All I really need to do is to subtract 9 from both sides, and in this case I combine the like terms with 16 minus 9, which is going to give us a positive 7, and that leaves us the vertex form of that quadratic function. Okay, so let's see that one more time in part B. This time in part B, again, I'm just going to kind of leave myself some space. The difference here being that we have a negative 2x instead of a positive value there, and then a negative 4. So I need to complete this square using the negative 2. And that's going to give me a positive 1 to add to both sides. I'm going to go ahead and rewrite this as a square of a binomial using that value, negative 1. And then I'm going to subtract 1 from both sides, leaving me x minus 1 squared minus 5. And that leaves me the vertex form of the quadratic function. So now you can change the standard form of quadratic function to vertex form using completing the square, and you could also change the standard form of a quadratic function using factoring to go to the intercept form. So that concludes our completing the square lessons.